Hello everyone, and thank you for attending our webinar, Exploring JIT Compilation in PHP 8. Before we begin, I'd like to cover 3 housekeeping items for our viewers. First, at the bottom of your audience console, you'll find a number of widgets for questions, slides, and additional resources. When you have questions for the presenter during the webcast, click on the Q&A widget and submit your question. We will answer as many as possible at the end of the webcast, and if we run out of time, we'll get back to you via email. Second, a copy of today's slide deck will be available in the resources folder at the bottom of your screen. Third and finally, if you need any tech support during the webinar, please use the help option. With that, I'll introduce our presenter for today's broadcast, Matthew Weir-O'Finney, Zen product owner and principal engineer. Matthew, thanks for joining us on today's broadcast.
Thanks for having me, Stephanie. My name is Matthew Weir-O'Finney. I am a product owner at Zen by Perforce, as well as a principal engineer. I began developing on Zen framework before its first public release and led the project for Zen from 2009 through 2019. During that last year or so, I helped transition Zen framework to the Linux Foundation under the new name, the Laminus Project, and I'm still currently serving as project lead to this day. I'm also a founding member of the PHP Framework Interop Group and work on the core committee currently and have helped to create a half dozen or more different standards for the PHP ecosystem. I'm currently on my second elected term of that. New section comes up next year, and I hope that others will be interested in joining the FIG as we develop standards in the coming years. So what are we talking about today? PHP 8 is coming out sometime before the end of the year. They're anticipating somewhere between the last week of January and the first week of December at this time. While the PHP release schedule plans for new minor releases with new features every year, new major releases are more infrequent and happen on a time cycle of more like 5 to 7 years. And generally speaking, they only happen when the core team wants to remove functionality that they previously deprecated, which helps them simplify maintenance and reduce bugs. When there are compelling changes to syntax or engine internals that could lead to backwards compatibility breaks. In other words, functionality that could change existing functionality and break it. Those are the two main reasons for them to bump the major version. Now, in terms of that first one where you were removing deprecated functionality, some examples of that with PHP 8 are, for instance, the fact that they're taking the XML RPC extension out of core and putting it into PECL, or the fact that they're removing the libxml disable entity loader function, which was previously used in various security features around XML. It's now obsolete due to changes in the underlying libxml library. So that is being removed, which of course affects functionality that you might have that was calling that function. Now, in terms of breaking compatibility, so when they are wanting to introduce features or make changes that break compatibility, some examples of that are, for instance, how PHP 8 is tightening up how it handles function argument contravariance and covariance in order to make it consistent and predictable. Those changes can sometimes break existing code. Things that you assumed were working before now suddenly might not work. Now, while most developers might not be affected by such a change, its impact can be subtle and lead to hard to identify errors if you're not aware of it. One of those features that's coming up in PHP 8 is the JIT. So the first thing we need to understand is, what is JIT? And to understand that, we need to understand how a PHP script is processed in the first place. So with normal non-optimized PHP, as a script is encountered, the engine goes and parses it and compiles it into what are called bytecodes or opcodes. In PHP, we usually refer to them as opcodes. Other languages will call them bytecodes. The two terms are interchangeable. Now, these opcodes are pseudo instructions that are then passed to a virtual machine. Now, PHP has a virtual machine. It does. If you run php-v or php-i in the command line, or if you execute php info, you'll see that it says the PHP version, and then always underneath it, it says Zend engine version such and such. The Zend engine is a virtual machine, and it's comparable to the Java virtual machine, the JVM, or the LLVM. Now, virtual machines in general, what happens is they allow any language to compile to bytecodes or opcodes that they understand, and then it will take care of the process of converting those then into machine codes. It makes it easier for languages then. They don't have to worry about compiling everything in the most optimal way down to machine code. They can compile to the opcodes, which is generally good enough, and it makes it possible when there's a good specification for a language to take that specification and target different VMs based on different features or performance that you might want to have. Now with PHP, we have one that is specific for the language, and that's the Zend engine. And the virtual machine's job then is to take the opcodes and compile them to machine code, which it can then execute. So the machine code is the lowest level of this particular process. So this is normal non-optimized PHP. This is the PHP we're most familiar with. Now, starting in PHP 5.5, the language introduced what was called the OPcache. These had existed via extensions before that. There was the APC, the alternative PHP cache. There was eAccelerator. There was also within the Zend ecosystem, we had the OPcache that was built into Zend server and Zend platform before that. What PHP 5.5 did was add an OPcache as part of the language. When the OPcache is enabled, what does is PHP takes the OPcaches that it's compiled to and pushes them into the cache. So if it encounters that script again, it sees, hey, I've encountered this again and I already have the OPcaches. It's able to skip that whole parsing step and go directly to passing it to the VM, which then has to compile it to machine code and execute it. Now, this, of course, helps improve performance because the parsing can sometimes be one of the bottlenecks. So this is a really good thing. This is something that helps speed up applications quite a bit, and it's where we started seeing performance improvements in PHP 5 happen. Now, it's worth noting that the OPcache is memory limited. It's like any sort of cache. So it can only store up to configured amount before it stops caching or it starts pushing out stuff that hasn't been used recently or frequently. To take this even further, PHP 7.4 added something else. When you have the OPcache, there's still some bottlenecks that can happen. And one of those bottlenecks is the fact that bootstrapping an application can tend to be very resource intensive. Most modern PHP frameworks tend to be bootstrap heavy. They go and gather configuration, they seed a dependency injection container, and otherwise initialize the application with various other tools. And those operations have to happen on every single request, and quite often can account for up to 25% of the request. So knowing that this is a common architecture, 7.4 introduced what's known as OPcache preloading. And essentially what this does is it's a mechanism that allows administrators, and it's administrators because you have to change a PHP INI value in order to opt into this. You specify a script that is going to go and precompile or list scripts to precompile into the OPcache during language startup. And so when mod PHP or PHP FPM start up their pools and they start loading up the language into memory, part of what it will do then is take that list of scripts, precompile them, and shove them into the OPcache. And so what that means is that the very first time you actually go and hit that script, it's already in the OPcache, and so it goes straight to the VM, which then compiles those bytecodes or opcodes and executes them. Now, just like the OPcache, because it is just a feature of the OPcache, it's still memory limited. And in fact, there's a kind of a tipping point that happens when you add too many entries to preload. And at that point, then it can either have no benefit or you can actually have some negative impacts to your performance. So you have to be very careful about how much you put into there. And you have to probably do a lot of benchmarking of your scripts to see what is that optimal point, what is too much, what is not enough in order to make use of this effectively. So that brings us finally to JIT. JIT, of course, stands for just-in-time compilation. And the idea is that you want to analyze those opcodes and figure out if it's something that you should go ahead and compile to machine code. And when you do, what will happen is when we identify a script that has made use of the just-in-time compiler, it will say, oh, hey, we already have machine code for this, and just go ahead and execute it. So you skip all the bits about the opcache entirely at that point. Now, the way it was originally written when they were working on this was that you would opt into this. You would mark something as something, a function or a method call as something that you wanted to shove into the just-in-time compiler. What happens now is actually there's two different ways of doing it. And what I'm showing here is what is called the function JIT. What this does is every single piece of code that goes through there, once it hits the VM, is passed to the JIT to analyze. And it then decides whether or not the code can actually be optimized and pre-compiled. And this is great because you can go through, you're looking every single time to see if this is code that's going to work. And if so, it goes ahead and compiles it. And this grows and grows over time. And so it has the potential to be insanely fast. Now, the problem, though, is that every single time we hit the VM, we are checking this code. And that introduces some of the first problems with this approach. The just-in-time compiler, and this is true across the board with every just-in-time compiler, is that it really only improves CPU-bound apps, things that are going to be executing over and over and over and over and over again. So things like graphics tend to work really well with this. Things like computations and scientific analysis, those sorts of things really work well with it. However, most real-life PHP applications are I/O bound. We're accessing databases, we're accessing other HTTP services, we're accessing caching layers, we're accessing the file system. That's where our slowdowns actually happen. The other thing for JIT is that it's only useful for apps with real hotspots. Another thing, words, things like loops and functions that are going to be called over and over again. When you consider the fact that PHP spawns a request and fires up everything, each and every request that comes in, it's hard to identify exactly where those hotspots actually are because you're only looking at this particular request. Another thing that's interesting is that the JIT compiler really doesn't like it when it has to infer any information about a type. It makes it harder for it to understand how to optimize the code. So it's a reason for you to use declare strict types. But if you aren't used to working with strict typing, it's going to be something that's going to be a bit of an uphill battle for you. That said, this is something I really, really hope that more developers start using is strict typing. It does help you with the correctness of your application and it avoids whole huge classes of errors. The other thing, speaking of classes, are that PHP classes and instances have to be relinked on each request, which means that the JIT actually can't refer to anything that's an object. And that means that for most modern PHP applications, which are heavily using object-oriented PHP code, the function JIT that I've described in the previous slide will not benefit that at all. The other thing is that because it analyzes every piece of code and it looks at every single path through every piece of code, it's going to go ahead and compile all of those paths, even if those paths never become executed. So in some ways, it's actually doing more work than it needs to. And that can introduce some overhead in addition to the overhead of the compilation time and the cache lookups. So the question then posed by the developers who are working on this, primarily Dmitry Strogov and Nikita Popov, they were trying to figure out then, okay, so this doesn't seem all that great. Is there a way that we could do this smarter? And so they did. And they introduced what is called a tracing JIT. And it adds yet another item onto this fun chart. The VM passes off information to a tracer at this point, and the tracer then goes and it has it develops what's called a trace, and that includes the actual VM instructions or the opcodes that are being used, what classes are and object instances are in the context, what functions or methods or closures were called, that sort of thing, and it creates this trace. And based on how often that trace is called, how complex it is, what operations are being called, so what opcodes are being used, it will decide then whether or not the code could benefit from being compiled. If it can, it goes in the JIT. Otherwise, we go back and we just execute it. This approach is a little bit smarter, and as a result, instead of compiling everything as it comes in, it does a little bit of analysis in order to determine that. And it's able to do it in a very smart way. And so, if certain opcodes are in there, it just immediately tosses it back. It's done. If it passes those tests that it's looking for, the opcodes are ones that it can optimize. The types that are being used are ones that it can optimize around. It knows that it's a hotspot or that there are certain loops in there. It will go ahead and throw it to the JIT. And so as time goes on, it gets faster and faster and faster. Now, how much faster? Well, that depends. PHP itself has a benchmark suite that it uses, and basically this is to ensure that we don't have regressions in performance between different versions of PHP. What it found with the JIT turned on in PHP 8 was that it turned out to be 3 times faster. Now, this is 3 times faster of something that's already insanely fast. To give an example, the benchmark, I believe, the benchmark suite, if I remember correctly, runs in something like 30 milliseconds under PHP 8. When you add the JIT into there, it runs in 10 milliseconds. The difference between 10 and 30 milliseconds is not a lot, but you can say it's 3 times faster, right? That's a true statement. Now, when you start looking at real world applications, it becomes something very different. With WordPress, what they're noticing is with the JIT turned on, and this is with tracing JIT, not function JIT, tracing JIT, it ends up being about 3 to 5% faster, which is good. It's not something to say no to, obviously, but it's not a whole lot of difference. This is, to give an example, the differences between different minor versions of PHP in the 7 series were often around this amount. So it's good, but it's nothing huge. Now, with framework-based applications, what they noticed was no difference. Now, this may seem like, okay, this is actually a good thing because what they had found before with function-based JIT was that quite often it actually was denigrating your performance. So you don't want that. You want it to stay at or better. And so this is actually a good thing. So knowing this, you're not going to necessarily get huge performance differences in the applications you're currently writing. The question then is going to be, what is it actually good for? The bad news is it's primarily benefiting CPU intensive workloads, but our PHP applications are not that. PHP's sweet spot has always been as a glue language for the web. It takes data from other sources and sticks it together after doing some processing and spits out a web page or an API payload. So we get something from a database. We get something from an API call to via HTTP. We do a cache lookup. We grab something from the file system. Those are the things that cause our performance bottlenecks. And there are ways that we can get around some of those. Asynchronous processing can be great if you're processing incoming files or workloads. There's a number of ways that you can kind of offset some of these already. The PHP language itself is typically not the bottleneck in these cases. That's the bad news. Now, the question then is, if that's the bad news and we're not really going to benefit a ton from this, then why did anybody bother developing the JIT in the first place? Well, besides the obvious answer of because I can, there's some more interesting nuanced answers. Nikita Popov, one of the PHP core developers, basically said these 3 things. The first is that we get significantly better performance for numerical calculations. So if you want to do financials, if you want to do scientific analysis, if you want to do processing of graphics and that sort of thing, that's the sort of stuff that actually does benefit from JIT. So if you want to do those things and you haven't been doing them on PHP because it's been too slow, with JIT, it might not be anymore. And so if you've been like pushing that stuff out via queue to other processes running in different languages, and you're not liking the fact that you now have multiple code bases, it's possible you won't need those multiple code bases anymore, which is really awesome. We get slightly better performance for typical PHP web applications. Again, it's fast enough most of the time, but hey, I'll take any better performance I can get. So let's go ahead and turn on that tracing JIT and get whatever we can out of it, right? But the third point is that we get the potential to move code from C to PHP because PHP is now sufficiently fast. Why is it sufficiently fast? Because the JIT can compile it to machine code, which means it's basically like having C. And this is a really cool thing. Now, why do I think that's cool? Yes, I did just say moving code from C to PHP. One of the new functions in PHP 8 is called stir contains, and it's essentially taking this signature of a string haystack and a string needle and returning a Boolean. If I were to write this in straight up PHP, this is what it would look like. I would have the body, the entire body would be one expression, and it'd be return false, not equal, stir pause, haystack, needle. Now, why did somebody develop stir contains? Because writing return false, not equal, stir pause, haystack, needle is really opaque. It's one of those things where you have to understand what somebody is trying to accomplish here. Stir pause returns the position of the needle in the haystack. Positions are zero based. The problem is 0 is considered a falsy value when you look at conditionals. And so the interesting part is stir pause returns false if it can't find the needle in the haystack. And so we can do a strict comparison against false in order to determine if the value is in there. This is one of those esoteric, wonderful, horrible things about PHP. And so somebody said, hey, why don't we develop stir contains? Now, the interesting part is they had to do it in C. Had this been coming in 8.1, they may have been able to write the source code for this in PHP itself. And one of the things that they're talking about is the potential to have contributions that actually are in PHP and then have the language use the just-in-time compiler to compile these to machine code as it is starting up. This sounds to me like a whole lot of fun. Now, let's get an even better example, because I think this will show you where it really can shine, I think. How many times have you wanted functions such as array reduce or array map or array filter to also accept a traversable object? One of the great things that PHP 5.1 and further added were these traversable interface and the iterators, which allow us to have objects that act like arrays. So we can pass them to a for each function, which is great. The problem is that if we want to use some of the wealth of array functions, particularly these functional programming ones like a reduce, map, and filter, we can't actually pass them to them directly. We have to use things like iterator to array before we pass them to it, which adds overhead and tends to slow things down. So we end up implementing this stuff in user land and our own collection objects and whatnot, and it's really ridiculous. What if we could write a function? So we write a function reduce that uses, oh, cool new feature of PHP 8, union types. So I can say array or traversable for the list. And I can say mixed for the initial value. This is really nice too, another feature of PHP 8. And then mixed for the return value of this function. And in there, I go and use a loop. Loops are one of those things that JIT really understands and loves. This sort of thing we could write in PHP. So one of the things I can see as being a possible huge benefit of having a JIT compiler is that we can start writing functions and stuff like this that are going to basically fix some of the features of PHP, give us new features that expand the capabilities without necessarily needing to write C in order to do it. And I think that's going to be actually a huge boon to the language going forward. So what else can we do with JIT besides extend the language though, right? What is something that you can use today? Well, one of those things is a static analysis tool. PHP 7 introduced what's known as the abstract syntax tree, or AST. What this does is basically it's a specific format in which those opcodes are generated, and it's done in a node-like, a tree-like sequence of nodes in order to describe the various operations that are happening. These tools are what the AST enables are static analysis tools. Static analysis basically looks at your code and figures out how correct it is. And it does that by taking a look at the types that are passed around, the paths through the application, that sort of thing. And it points out where we're making assumptions that may not actually be backed by reality, such as assuming that a variable we assign is of a certain type or that a condition is going to be reached. These tools can really help you eliminate a whole bunch of different bugs in your application and make sure that things work together in ways that are predictable and without bugs. However, the tools are also somewhat slow. If you've used PHP Stan or Psalm over even a smaller, I would say it doesn't even really matter how big the component is. We've been integrating Psalm into a bunch of the Laminas components over the last couple of months. And even on some of the smaller ones, running the analysis can take a while. What's cool is that initial benchmarks created by the developers of these tools have demonstrated that PHP with JIT can make them as much as twice as fast. And that may not seem like a huge deal, but it is a really big deal when, as you're developing, you're able to run these as you go and get feedback almost immediately. When you have to wait for the feedback, it's easy to sit back, have a coffee, and then forget what you were doing beforehand. If you get the feedback immediately, you're constantly saying, oh, that's green, or oh, that's red. That sort of thing helps a ton. So being able to run these static analysis tools as part of a continuous feedback loop and not have to wait for them is going to be a huge boon to you. So that's one place where JIT is going to benefit your applications right away. Another place that you might be able to use JIT is with machine learning and big data. Machine learning is the process of teaching a program how to make accurate predictions by feeding it data. And the term big data describes a context in which machine learning is applied. It's extraction and analysis of large and or complex data sets, and then passing it to a rule set so that you can learn from it, or rather your computer and the program can learn from it. Machine learning requires huge data sets in order to provide reasonable accuracy. Typically, what happens is they are getting a fire hose of data and they're processing it continuously in order to train themselves based on the rules you've defined. Python, of all languages, has dominated the machine learning ecosystem for years. And the reason is because it allows wrapping C libraries easily, but also because it has expressiveness of an interpreted language. When you look at languages like C, it's much harder to write this sort of thing. You can write them in Go or Rust, and people do, but there's fewer people who have that experience because you typically need a stronger programming background in order to do it. One of my sons is in college and is learning Python currently. He had never even touched Python until college and is already doing machine learning stuff. That's how easy it is to start up. And really, it's that combination of the two. When you have a difficult language to write, or that it requires a compilation step test, it's going to restrict the number of people who can develop it. And if the language isn't fast enough, it's just no good for processing the large data sets. So you really need something that can do both. And that's where the JIT comes in, because JIT works best with CPU intensive processing. Ooh, that's data, right? And PHP is itself an eminently learnable form, right? It's one of the easiest languages to pick up. It's very expressive. It's pretty easy. Yes, it has quirks. It's not always pretty, but it's as easy or easier to pick up than a lot of languages out there, including Ruby or Python. There's a reason there are so many people out there who get their start on PHP. So this is one of those places I think is going to benefit hugely from the JIT compiler, is the ability to do machine learning with big data in PHP. And I think we're going to see some of the existing libraries such as Rubix and PHP ML start optimizing themselves so that they will work really, really well with JIT, which means that they're going to become really viable as alternatives to using other languages. And one of the things that's hugely beneficial here, I think, is the fact that we can, PHP is geared towards the web. So it becomes really easy to have an API endpoint that is getting a stream of data coming in and processing it continuously. And I think that's going to be a place where PHP is going to really shine in the coming years. Now, another area that I find rather interesting is daemons and system programming. PHP itself was developed as a web-first language and has a shared nothing architecture where the entire application gets initialized, executed, and torn down at each request. And we talked about that earlier. It's like the whole reason the OPcache preloading exists is because of that shared nothing architecture. That shared nothing architecture makes it arguably easier to learn than other languages like Java or C# because you don't have to worry about things like garbage collection, state, compiling, compile errors, all that stuff, right? And that's great. But it means that we have often not worked with systems programming in this case. When we do write daemons in PHP, you find that you start ending up having to do things like track state and make sure that things are as stateless as possible. You have to make sure that the performance is going to remain fairly static. If performance starts to degrade, then you have to restart your daemons and everything. You have to have monitoring sitting in front of it. It's no good. Now, JIT adds some interest to this because JIT works best when it has information about what is executed before. The tracing JIT learns as it goes. And so it actually makes it possible for a long-running process to get more efficient over time. And so that's going to open the gates, I think, for a lot of system daemons written in PHP, because they'll be able to start improving their performance the longer they run. I'm personally really excited to see what sorts of performance optimizations I'm going to see happening when running Swool-based web servers, because if these are already long-running, they're already very stable, and if I can start, have a JIT in there that is going to be making things more optimized over time, I think that's going to make it a really powerful combination. So one of the things I see also being enabled by the JIT is the possibility for PHP to move from a general purpose web language to a general purpose systems programming language that just also happens to excel at handling and serving web applications. So at this point, you might be wondering, how do you get started? And it comes down to 4 settings in your PHP INI file. And 2 of these have existed since 5.5. The first 2, OPcache enable and enable CLI, you have to enable those first. It will not work without it because it works in tandem with the OPcache. Then you need to tell the JIT the buffer size. So this is how much memory it should assign for compiling, compiling the different snippets. How much is it allowed to keep in memory at any given time? I believe 32 megabytes is the default and or recommended. You can make it as big or as small as you need it to be. And then turn it on to tracing. The other value here is function. Don't use it, use tracing. Tracing is the one that learns as it goes instead of just blindly trying to optimize everything. So you want to have it in the tracing mode. That's going to be the one that actually gives you some performance benefit. So that's all you have to do to get started. Those 4 lines in your php.ini file that will enable it for your FPM processes, for your mod PHP processes, and for your CLI. Now, what is the future of JIT in the language? We've talked about it being used to potentially enable new features in JIT, but the other question is going to be, what are the improvements that they are planning now that they've got this initial implementation ready for PHP 8? So the first one is that they're going to add support for more VM instructions. As I said with the tracing JIT, part of what it's looking at are what operations or opcodes is it trying to run, and if is it something that it can actually optimize at this time. So it's being very selective about it. It's a very narrow set of opcodes that it will actually try and optimize. If it falls outside of that range, that's one of those things, then that trace gets thrown back to the VM, and the VM processes as normal. So one of those things they're going to be doing is identifying what other VM instructions might be interesting and might be ones that they can optimize and thus make use of the JIT for. They're also going to be looking at more and better optimizations. Part of what the JIT does is not only compile it to machine language, but it does some optimizations to make sure it's as fast as it can possibly be. So they're going to be looking at figuring out what are ways that we can compile to machine code in a way that will make it even faster. The third area that you'll likely see improvements on in the future, the foreign function interface was introduced in PHP 7.4. And this is an extension that allows you to wrap C libraries and expose them to PHP. Right now, the JIT does not do anything with those. It basically says, I don't know about those. I don't know how to optimize those. I'm not going to do anything with those. That's one of the things that they've already identified is something that they want to figure out how to throw to the JIT compiler so that we can also get performance out of those as well. And then finally, part of all this process that started really with the development for PHP 7 and now is continuing into PHP 8 with the JIT is going to be finding places in the PHP source code and particularly in the Zen engine that they can eliminate further bottlenecks, and those feed more into the optimizations that are listed here on the second point here. So those are things as well that you can be looking for in the future. These are all things that are going to be fairly low level, but what they will do is help improve the JIT over time so that it can actually help improve performance in the language as a whole as it gets smarter and more capable. So at this time, I would love to hear your questions if you have any. And thanks for joining me today as we did this little traversal of JIT and how it's going to affect your applications in PHP.
All right, thank you, Matthew. We have a couple minutes left here for some questions. One of the first questions we got here says, should I turn on JIT if I am writing my own application or a framework-based one?
Right. I mentioned it earlier that you don't necessarily get any benefit from the JIT at this time, but it also doesn't make it any slower. One of the things I say is if it's not making it slower and has the potential to put in to increase performance, just go ahead and turn it on. You can gradually optimize your code to make it better. And one of the ways you can do that is using those static analysis tools such as PHP Stan or Psalm. One of the things they do is help you make your code more correct. And they point out when there's too many ways out of a particular function, too many types that can be returned by a function, too many types that can be accepted by a function, that sort of thing. And what those do is they help you write better code. The side benefit of that is that better code then is more likely to be able to be optimized by the JIT. So I say turn it on, start using a static analysis tool, and you will start getting benefits over time.
All right, the next question we have says, should I convert my code over to pure functions instead of using object-oriented programming so it makes better use of JIT?
That's a good question. So the way that this works out, I mentioned before that the function JIT, for instance, works best when we're working with functions and not with objects and classes. That's not necessarily true with tracing JIT because it has the ability to understand context, including the classes and methods that are in the context of that particular trace. So there's no necessarily good reason to switch to functional programming. Now, that said, when you start looking at functional programming, you tend to make better decisions about how your methods work and how your functions work. You can do a nice mixture of object-oriented programming and functional programming by making sure that you're not storing state in your objects and making sure that you are using as few types as possible in your arguments and your return values. essentially the fewer paths through your methods, the easier it is going to be for JIT to be able to do its work. And the fewer paths through your methods is one of those things that functional programming really, really harps on, is you want to make it as easy and idempotent as possible, that with this set of arguments, you're always going to get this result back. So you don't need to move to purely functional, but it is something to keep in mind as you're doing this, because you will get better benefits from the JIT if you were thinking in a functional way as you do your object-oriented programming. Are there any other questions?
Well, we're actually out of time. So if we didn't get to your question, we'll reach out to you via email. Thanks to our audience for your attendance and participation today. And thanks again to our presenter, Matthew.
Thanks, everyone.